If you have even a casual interest in weather, you're probably at least a little bit familiar with the Storm Prediction Center website, which I'm on right now. And one of the things they do is this convective outlook, which shows you over the next few days, where in the United States is there any severe weather risk, if any, and, how big is the risk. So, for instance, if I go to today's outlook, there's a slight risk around Indiana, but really not a whole lot going on for today. We can go to these categories to get the specific tornado, wind, and hail probabilities. But the categories go from marginal, which is the lowest risk, to slight, enhanced, moderate, and then high, which is the highest risk. And not surprisingly, most days that there's severe weather, it's going to be a marginal or slight risk. Enhanced and moderate is a little bit less common, and then high is pretty rare. Usually once or twice a year they might issue a high risk. And in fact, there's a Wikipedia page, list of Storm Prediction Center high risk days, which you might find to be interesting. Basically, this has all of the SPC high risk days that have been issued since the mid 80s. So if you want to see how often does your area go under a high risk of severe weather. But anyway, one of the things that I wanted to do with these maps was try to automatically analyze them using a script and then convert it to some sort of summary that, I can use for various purposes. One of the things I'm doing is sending it to our company chat, which is on Slack. So every morning it downloads the images and analyzes them, and if there's a severe weather risk for the day, it says, hey, today there's an enhanced risk of severe weather, 5% chance of tornado, 30% chance of wind, 15% hail, that sort of thing, just so that we know, if there's a concern for that the weather could get bad later in the day. So the way that I did that was, first you want to look at the image in an image editing program and get some information from that. So for instance, we want to know what are the pixel values on the image that correspond to our location, and then what are the color values of these risk categories, as well as the probabilities that we need to look for on those pixels. Now, if I view this image, I can get the URL to just download that image. However, the exact file name actually depends on the time of day, and I'll get to that a little later. But right now, this isn't a very interesting image. Like I said, there's not a whole lot going on today. So specifically for my location here in the Quad Cities, there's no storms today or anything. So what I'm going to do first is go to the archive here. And I know that on 2013, June 12th, we did have a high risk of severe weather for this area. So I'm going to use that map to look at just for something a little bit more interesting. I think it was by the 1630 that we had the high risk. Yeah. So let's get the URL and copy it. I'm just going to use the wget utility to download that. And that just downloads that file to the same directory. So first of all, okay, so this is an 815 by 555 pixel image. It's useful to know if you're going to be trying to analyze the image. And then for getting everything else, I'm going to use GIMP, which is an image editing software. Okay, so here's our map. You can see in the bottom left hand here, it shows the pixel coordinates that my cursor is currently on. So if I'm on the top left of the image, it's 0, 0, or close to that. And at the bottom right, it should be our 815 by 555. My location is right around here somewhere, 505 by 208. I actually, instead of just using one pixel value for our location, we might want to generate a range, or, say a box of 10 by 10 pixels that is just our general location. A couple of reasons why you might want to do that, just to make sure that your pixel is not right on the state line, which would just give you a gray color value each time, because that gets through these fill colors here. And then also we don't want to hit the outline of the category risk, which is a slightly different color than the color that is used inside of that. But anyway, then we want to get, what are these specific colors? So I'm going to be using the color picker tool, and then click inside of the high risk. So that gives us that pink color, which specifically is, so that is, the RGB values are 255 by 127 and 255, and then the moderate risk is 230, 127, 127, and then the slight risk is 245, 246, 127. Apparently back in 2013, there was no marginal risk or enhanced risk, so I had to use a different image to get those, but that's how I did it, basically, just using this program, and that's all we need to know for now, our location pixel range and those colors. So let's go back and, I guess now let's just look at the script. So just as a warning, I did for some reason write this in PHP, so if you hate PHP, I apologize. And also, this should not be used as an example of good coding practice. It's just something that I wrote very quickly until it worked, and then I left it at that. So just be aware of that. So this is, let's go to the top. So the first thing I did was to just keep track of these URLs that are used for all 4 of the maps that we want to use. And then I've got the file names for that as well. And then these parameters here, the Xmax 815, that's the width of the image, so that's the maximum possible X value. And then the X offset, that is just the left side of the location box that I defined, and then the Y offset is the top of the location box. And then the X length and Y length, that's just how much we have to add to those offsets to get to the bottom right portion of that box. So that those are the only pixels in the image that we're concerned about. So the next thing we do is use wget to download the map file, and then we use ffmpeg to convert it to a raw uncompressed image file, which is a little bit easier to deal with in a script. And then we open a file pointer to that raw uncompressed image. And then this first loop here, what that does is this goes through, it essentially just discards this entire top part of the image until we get to that top side of the location box. And so the next value that we pull from that pointer is going to be right around here somewhere. It's going to be on the left side of the image, but 200 pixels down from the top. So it's going to be, the XY coordinates would be 0, 200. And then for each line here, we're going to read across until we get to that left side of the location box. And then we start reading those pixels until we get to the past that length, the right side of the box. And then we don't care about any of the rest of the line after that. And then we do the same thing for the next Y value. Go to the left side of the box, and then read to the right side of it, and then we don't care about the rest of the lines after that. So it just keeps going like that. Actually, first that happens with this loop right here. So the Y length, that is, wait, just make sure I know what I'm talking about here. Oh, I see. So the outside loop is just going from the Y value of 0, which is now actually 200. So it's going to read from 200 Y value down to the line that corresponds to Y length, which is 15. So it's only going to read those middle 15 lines, and then it doesn't care about any of the rest of the image after that. And so the inner loop is looking at the X values. So that's just going from 0 to X max, which is the entire width of the image. But then specifically, there's an if statement inside of that, which we only are concerned about the pixels between the X offset and the X offset plus the X length. So this is actually a 20 by 15 box that starts at that 490 to 200. That's what I chose specifically. But basically, if it's within that location box, then we get here. So what it's doing here is for each of the 5 categories, so marginal, slight, moderate, enhanced, moderate, high, we're seeing if we can match that color with the current pixel value that we're on. And this ORD function that converts the binary character to an integer that's between 0 and 255 so that we can use it a bit more conveniently. And so for the pixel, we've got the RGB value, and we're just comparing that to the colors that we defined up here. So these are the category colors, and then these are the colors for the probability, the tornado probabilities, which goes from 2% to 60%. I don't think I ever found anything with a 60%, but the wind and hail is the same. So that goes from 5 to 60%, same colors. And then, so for each pixel, we record that value as this max variable. And the reason that I do that is because, say that the box encompasses both this high risk and this moderate risk. Well, which one do we report? Probably the high risk, because that's a higher risk. We're more concerned about that. So, that just ensures that for the entire range of pixels that we're looking at, it picks the highest risk for the category, and then for the tornado and the wind and hail. So anytime that another pixel we look at has a higher probability, then we record that one, and then we'll use that later at the last part of the script. So just to clean up, it closes the file pointer, and then it removes or it deletes the uncompressed image as well as the image that we downloaded. And then this part right here, if there's no severe weather risk for the day, there's no point in continuing the script, so it exits right here. If there's at least a moderate risk, then we continue down here to the tornado probability. And, again, this is where I'm saying that this is not good coding practice. This is pretty much exactly the same code, just a little bit different. It's looking at the probabilities, and there's 6 categories instead of 5, but, it should probably all be a function that is just reused 4 times, and that would be much more organized. But, for now, this is how I've got it written. So, it's all the same as the category. We're just looking for the pixels in our location box, and then we're looking for if any of those have a color which corresponds to a tornado probability. And then we clean up again, and then we go on to the wind probabilities, and then the hail probabilities. Okay, and then the last part is to take our category numbers or our probability numbers and then convert it to a little bit more human readable form. So I'm using the abbreviations for marginal, slight, enhanced, moderate, high, or none. And then, if we make it down to the rest of it, we've got the percentage of tornado, percentage of wind, and then hail. And then the last line is that we JSON encode this object so that we have it as in JSON format, which is a little bit easier to use in a web app, and then it sends that to a temporary file. So every morning, there's actually just a cron job that kicks off and looks at that temporary file, and if there's a risk, it converts it into an even more human readable form. So it would be something like, today there is a moderate risk of severe weather with a 10% tornado chance, a 45% wind chance, 15% hail chance, something like that, just so that we know to, be on the lookout for, worsening weather conditions. But yeah, I don't know if I mentioned it earlier, but I'm actually sending it to our company chat on Slack. So that was my main motivation for writing this in the first place. But I imagine there are all sorts of uses that you might find for this sort of thing. So if I just run this, there's no severe weather for my area, so it's probably not going to find anything. None, no risk today. However, the second script is actually just an edit of the first one. I changed the file names and the URLs for that 2013 for this day where we did have a high risk. So, and everything else on this is exactly the same. So let's run this one. So you can see it made it farther through the script. And then, again, these echoes are just debug. They're not really important. But let's look at that temp file again. Okay, so here we have the high risk, the 15% tornado risk, wind 60%, and hail 30%. So, yeah, basically every day it just gets this, it generates this JSON, and then the web app, or the Slack app, reads that, and then it alerts the company if there's a risk for bad weather for any time in today. And that's pretty much all there is to it. Trying to think if I left anything out. I did mention that the file would change based on the time of day, and you can see this one says 1630, but I'm in the actual script, I'm looking at the 1300 hours map, which actually can, that's actually a local time for me of 8 a.m. So every morning at 8 a.m. is when it checks, but you can set the time. Every few hours they issue a new Outlook, so just, get the one that you want, and, everything else will be taken care of. So I guess that is all, I think. If you have any questions, let me know in the comments, or if there's any other programming or scripting stuff like this that you want me to cover, I will see what I can do on that. I know that a lot of people want me to do a video on audio synthesizing, which I'm using a similar unconventional technique of programming languages to do that, but that one's going to be a little bit more difficult to explain, but I do plan on getting to it at some point. Not sure when, but yeah. Anyway, that is all for now. Talk to you later.